Hello everyone. This video is on the Knewton Alta assignment for section 7.6 called Solving Quadratic Equations by Factoring. Alright, so in this video I'm going to be doing a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are all the same. The structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Alright, so on the assignment page you should have the title, the mastery bar telling you how far along you've gotten, the objectives, and it looks like there are 3 objectives in this assignment. Under the current objective, there should be a question related to that objective. And at the bottom of every question, you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. This is for instructors only. But you will have a more instruction button. So if you're ever struggling with a topic or a particular question, click on this and you'll be taken to a page with some reading or videos to study. And then you'll be given questions related to that instruction. And completing those questions is another way to progress through the assignment. Alright, so the first objective I'm looking at is solve a factored quadratic equation using the zero product property. Alright, so before I get into this actual question, I want to talk about solving a quadratic equation, the steps we're going to follow by factoring. And then this zero product property will come up. Alright. So solving a quadratic equation by factoring. Alright, so the first step is to get the equation in the general form for a quadratic. Get the equation into the following form. So you're going to be adding and subtracting terms to both sides until it looks like this. Ax squared plus bx plus c, and this should be familiar to you. Alright, this is the typical quadratic polynomial with one variable. A, b, and c are just numbers, right, just coefficients, equals 0. So you do things to multiply out and add and subtract terms, get everything to one side, 0 on the other. So you have a quadratic polynomial in standard form on one side, 0 on the other, okay? Then, step 2 is to factor the polynomial completely, which you should know how to do. I'm not going to go over new methods or anything, teach you methods. That's from sections 7.1 through 7.5, right? This entire chapter, you've been learning how to factor polynomials. Factor the polynomial completely. Alright, so once you factor the polynomial, then you're going to use what's called the zero product property. The zero product property. And the zero product property states the following. If a product is equal to 0, so if you have a product equal to 0, then at least one of the factors must be 0. So at least one of the factors of that product must be 0. Now, a way they've written this in symbols is the following. It's if, A times B, right, here's a product, equals 0. And there doesn't have to be just 2 factors in the product. There can be 3 factors, 4 factors. But for the most part, in this particular assignment, we're going to see 2-factor products. If a product equals 0, then maybe the first factor equals 0, or the second factor equals 0, or both, but at least one of those equals 0. That's what that's saying. So we're going to use the zero product property to basically split the equation up into 2 separate equations, and then I'll say solve and check. That should be the last step in every single equation you're ever given, whether it's a quadratic equation or linear equation or whatever. And you always check your solutions, back in the original equation. Plug in the values for the variables and see if it makes it true. Right, but this is the zero product property that's being talked about in this particular question, right? The first question I'm given has to do with the zero product property. So they're saying here, see, solve x times x minus 3. See, the left side is a product. X times x minus 3 equals 0. Right? The product equals 0. That's the beginning of the zero product property. If a product equals 0, then at least one of the factors has to be 0. Right? So this is what we're going to do with this. Right? I'll write this out. So here I'll keep the zero product property up. So we have here, they wrote it out like this. It's x times x minus 3 is equal to 0. Right? So I have exactly what I want, exactly the beginning of the zero product property, the hypothesis. We have a product of several factors on one side, right? Here's a product equal to 0, and it must be 0 on the other side, right? It can't be a product equal to another number. You can't do this zero product property, you can't apply it unless the product is actually equal to 0. So by the zero product property, right, and I'm just going to abbreviate zero product property as ZPP for the rest of this video. So by the zero product property, one of these factors, at least one of them, must be equal to 0 then. Right? So either x is equal to 0, or the other factor, x minus 3, equals 0. Right, so you see what happened here is we took one equation and kind of split it up into multiple equations. And then comes the last step, right, where we take each of these separate equations. We're going to solve each of these and check our solutions, back in the original equations, of course. Right? Solve these and check. Now, the first equation is not a problem. The variable is already solved for. Right? X equals 0. And the next equation, x minus 3 equals 0, I would just simply add 3 to both sides. We get x equals 3. And then I'm not going to circle them yet. What I'm going to do is check them back in the original equation. Again, always check in the original equation. Alright, so I'll do that here. Let's check when x equals 0. Does it work? So I'd have 0 times 0 minus 3, right, replacing all the x's with 0, equals 0, and then, this is just 0 times negative 3 equals 0, and then remember, anything times 0 is 0. That's the whole crux of the zero product property. We get 0 equals 0, yes, right, so x equals 0 works. That is a solution of this equation. And then I'll check x equals 3. So again, taking the equation, replacing all the x's with 3. So the first factor becomes 3, and then in the second factor in this product we have 3 minus 3. And is that equal to 0? Well, yeah, this is 3 times, and then 3 minus 3 is 0. And then we get 0 equals 0, right? Because anything times 0 is 0. That works as well. So this equation has two solutions, 0 and 3. And that's what we're asked to type in, right? The solutions. Now they're saying, multiple answers, if any, should be separated by commas, right? And enter only integers or fractions. So they already have the x equals for us. We just need to put the answers. 0 was a solution, comma, and then 3 was another solution. That's what they meant by multiple answers should be separated by commas. All right, and then once you submit an answer, you'll be told if you're right or wrong, and then given some sort of answer explanation. Please read through the answer explanations, right, just to make sure you understand why something was correct or incorrect, and hopefully you can learn from your mistakes for future questions. All right, so moving on. All right, so here's a solve applications modeled by quadratic equations. All right, so these are word problems. Now, just like any word problem, though, you read through the problem, you assign expressions to unknowns, and then using those expressions, you translate some words, translate sentences into equations. All right, so I'll actually write this one out. It's not very long. It just says the product of two positive consecutive integers is 462. There's an equation there. You got is equals. Find the integers, and of course it says again, separate your answers with a comma, right, if there are multiple answers. All right, so I'm going to be doing this, once we get the equation written, I'll follow this procedure to solve the equation. All right, get everything on one side in this form, ax squared plus bx plus c equals 0, factor, use the zero product property, solve and check. All right, I'm going to be doing all that every single time. So once again, I'll write out their statement. The product, so that implies multiplication, right? Product. The product of two consecutive positive integers, two positive consecutive integers, is 462. Right? That's the sentence that's going to be turned into an equation. Now the two unknowns here are these integers. So like the first integer, I'll say the smallest the smaller of the two integers, and then the next one, the first integer and the second integer. I don't know what these are. I'll call them something. Now you can call them like x and y or m and n. You can call them two different letters, but they gave us a key here. They are consecutive integers. Remember what that means. That just means, you just add 1 from 1 to get to, 4 and 5, these are consecutive integers. 10 and 11, these are consecutive integers. You just add 1, right, to get from one to the next. So if I call the first integer x, the next integer is the next consecutive integer. I'm just going to call that x plus 1. I hope that makes sense. All right, and then the left side of the statement here, the product of these consecutive integers, that means multiply them. So x times x plus 1 is means equals, right? We'll translate to equals, and then 462 on the other side. Right? And now I'm solving this equation. And I'm going to solve it by factoring. Okay, now be careful. Too many people make the mistake of saying, oh, I've got a product here, I can use that product property. But no, remember it was called the zero product property? The number on the right side here is not 0. It's 462. So you can't split this up. You can't use that product property. Right? It's got to be the 0 product property. You know, the only time you know when a factor is going to be 0 is when the other side is actually 0, when the product equals 0. So the first step, like I said, is going to get into that ax squared plus bx plus c equals 0 form. So I'm going to multiply this out. Right? So the left side is x squared plus x, right, after distributing the x, equals 462. And then I need to subtract 462. Let's separate this. We have x squared plus x, and then subtracting 462 will give me minus 462 equals 0. Now I have it in that form that I want. Ax squared plus bx plus c equals 0. And then we factor this polynomial here. Now we're lucky, this is a quadratic with a lead coefficient of 1. So now all I'm looking for are factors. Again, if you go back and through chapter 7, learn how to factor again if you don't remember. But we're looking for factors of the constant term, negative 462, whose sum is positive 1, right? The middle coefficient, the linear coefficient. Alright, so just for this first one, I'll make a little chart to help us factor. And you've seen me do this in earlier videos and earlier assignments. Now, if the number we're breaking down is negative, that means one factor has to be negative, one factor has to be positive, and I would like the sum to be positive, right? Positive 1. So I'd like the positive factor to have a bigger magnitude than the negative factor. So like negative 1 and positive 462, right? Those multiply to be negative 462, but they add up to be 461, right? So clearly not those. Those don't add up to 1. Negative 2 and 231. Right, these would multiply to be negative 462, but clearly they would add to be 229. Right, now we're getting closer to 1, but that's definitely not 1. 3 goes into this, right? Negative 3. And if you see it already, or you can use a calculator to help you out, that's fine too. But let's see, 3 goes into 462 154 times. Right, because that'd be a 450 plus 12, yeah. And then if you add these up, that's 151. Right, so we're getting closer to 1, but not 1 itself. 4 doesn't go into this because the last two digits aren't a multiple of 4. 62 is not a multiple of 4. It's not a multiple of 5. It is a multiple of 6 because 2 and 3 go into it. So let's see, negative 6, and this would be 6 times 77. Right, 420 and 42. Alright, again, we're getting closer. These add up to 71, not 1. Let's see. Yeah, we see that 77's a factor, so 7's a factor. And it would be negative 7 times 66. Right, because again, 7 times 11, put the 11 on the 6. These add up to 59. Not that. Alright, and then so again, I mean, I can break down 462 right here. We know it's 2 times 3 times 7 times 11, don't we? Alright, because it's 6 times 77. So this will help me out. 8 isn't a factor, 9 isn't a factor, 10 isn't a factor, 11 is though. Actually, you know what? I can see it right now. That's a lot better. 22 and 21, right? Just to save some time here. Negative 21 and positive 22. These multiply to be negative 462, and they add to be 1. So these are the factors I'm looking for. So this actually factors then, kind of moving down here to x minus 21 times x plus 22. Remember, when the lead coefficient is 1, it's really that simple once you find these factors. And now I have what I want. All right, now I have a product equal to 0. All right, so now I can apply that zero product property, right? By the zero product property, one of these factors, at least one of them, has to be 0. So either x minus 21 is equal to 0, or x plus 22 is equal to 0. And then we solve each of these and see, which ones actually make sense with the problem. So x equals 21. Now if x equals 21, my integers would be 21. The first integer would be 21, the second integer would be 22. And there's one answer, and that works. There's two positive consecutive integers whose product is 462. So this is good. And this is what I'm going to put in the assignment, right? The two integers they're looking for are 21 and 22. Then here, x equals negative 22. Well, if that were the case, the first integer would be negative 22, and then the next integer would be plus 1, negative 21. Now these do multiply to be 462. That's true, but they're not positive. See, the question asks for two positive consecutive integers. These are negative consecutive integers whose product is 462. So the answer I'm putting in is 21 and 22. Right, after all that. So 21, 22. Those are the two positive consecutive integers whose product is 462. And again, that took me a while because of the factors. Like I said, though, if you see it right away, or you could use a calculator to help you out find those factors, that'll be a lot easier. Great. All right, so moving on. So here's another application where they're asking for the width and length of a rectangle. All right, so the area of a rectangular patio is 400 square feet. Now remember, area is length times width, the area of a rectangle. And they're telling us the length of the patio is 9 feet more than the width. So I'll write this up in letters, right? Right, so the area of, they're telling us the area of the rectangle is 440 square feet. And if I call the length, L, and the width W, we have the following. L times W equals 440. All right, but that's not a quadratic equation in one variable. It's got two variables. I want one variable. We're only used to one variable at this point. But they did tell us that the length is 9 more than the width. All right, they said the length of the patio is 9 feet more than its width. L equals W plus 9. And so I'm going to make a substitution here. Right? This is saying L is the same thing as W plus 9. So I'm going to make a substitute. This L I'm going to replace with W plus 9. So now we have this equation. W plus 9 times W equals 440. And we're solving this. Now we have it. This will be a you'll see that this is a quadratic equation in W. And I'm going to solve this for W, and then we'll find L, and that'll be our length and width. Now again, don't make the mistake that a lot of people make when they first do this. See, I see a product equal to not 0. This is 440. So I can't use that product property here. All right, it's got to be a product equal to 0. I Can't say that enough. So I need to first do what I did in the last example, multiply this out, get everything to one side, get it in that standard form. So we have w squared plus 9w equals 440. Almost there, and then subtract 440, and we have what I want. W squared plus 9w minus 440 equals 0. Okay. And now I'm on ax squared plus bx plus c equals 0, but instead of x it's w, right? It's in that standard form, general form, whatever, for a quadratic equation. And now I factor this side. And once again, it's a nice quadratic where the lead coefficient is 1. So I just need to find factors of negative 440 whose sum is positive 9. Now 440, this is 44 times 10. This is 2 times 22 times 2 times 5. So 2 times 2 times 2 times 5 times 11, if you broke it down to complete primes there. And let's see, what would be add up to 9 if one would, again, this is negative, so one of these got to be negative, one of them's got to be positive. Let's see, 10 and 44, no. 20 and 22 don't have a difference of 9. 40 and 11. Alright, so I'll think about this a little bit. Alright, so this is bad because I just realized, and you've probably been screaming at me this entire time, if you read the problem, it actually said the area was 400. I was like, man, there's something wrong here. That's because I wrote the number wrong. So my apologies for this, but this should be 400. Alright, so ignore all that junk. The area of the rectangle was 400 square feet, not 440. I don't know why I wrote 440, and I do apologize. But everything else is correct. The length was the width plus 9. W plus 9 times W equals 400 now. Subtract the 400. So now I'm looking for factors of 400 that add up to 9. Negative 400 that add up to 9. Alright, so I'll do something similar over here. Maybe this will be easier. Now 400 is, clearly 4 times 100, which is 2 times 2 times, and this is 2 times 2 times 5 times 5, right? 4 times 25. Okay, so yeah, 16 and 25, those differ by 9. Right, so the factors I'm looking for then would be positive 25 and negative 16. So W plus 25 times W minus 16. All right, so again, my apologies for the 440. All right, if you want to, again, I apologize for that. Just be careful when you're writing stuff. All right. But now I have what I want. Right? I have a product equal to 0. W plus 25 times W minus 16 equals 0. And since I have a product equal to 0, I can now apply that 0 product property, right? By the ZPP, one factor equals 0 or the other one. Right? So either W plus 25 equals 0 or W minus 16 equals 0. And then we solve these and see which one actually makes sense with the problem. First equation, W is going to be equal to negative 25. But remember, W represents the width of a rectangle. Width can't be negative. Alright, width is some sort of measurement of distance, right? We're not going to talk about negative width. Width has to be a positive quantity, so I'm not using that one. I will use the other one though, right? W minus 16 equals 0 implies that W equals 16. Alright, and the area was given in square feet, so this will be in feet. Right? So there's the width. And then remember the length of the rectangle is just the width plus 9. 16 plus 9 is 25 feet. Right, and there's the length. And 25 times 16 is 400, right? So the area of the rectangle is correctly 400 square feet. All right, now they already have the words feet in there, and just pay attention to what means what. The width was 16 feet, the length 25 feet. And again, I apologize, I miswrote the 400 as 440, but I fixed it. All right. All right. Okay. Next. All right, so now here's a quadratic equation. Solve it by factoring. So hopefully I copy it down correctly. All right, so the equation I'm given is 144 d squared minus 96d equals negative 16. So remember, that first step in solving these quadratic equations is to get everything on one side. It's 144 d squared minus 96d, and then plus 16, right? I would add 16 to get rid of that negative 16 over there, equals 0. And then you start factoring this polynomial. Now remember, the first step in factoring is pull out the greatest common factor, right? So far there hasn't been a common factor other than 1. But now in this problem, all the coefficients are a multiple of 16. The greatest common factor is 16. So I'm going to pull that out. So we have 16 times, and then 16 times 9 is 144. All right, 90 plus 54. So that's 9d squared minus, and 16 times 6 is 96, right? 60 and 36 minus 6d, and then plus 1 equals 0. And then I recognize it, maybe you do too, but this 9d squared minus 6d plus 1 is actually a perfect square trinomial. It's 3d to the second minus 2 times 3d times 1 plus 1 squared. So this will factor to the same factor twice. It's actually 3d minus 1, squared. And there we go. And now I have a product equal to 0. There are technically 3 factors here. But because, one of them is just the same factor twice, I don't need to write that twice, right? So by the 0 product property, either 16 equals 0, but nothing's coming from that, right? 16 is not equal to 0, or, one of the other factors. Well, the only other factor is 3d minus 1. Right? It just so happens to be a factor twice. So they might call this a repeated solution. We'd get d equals 1/3 here. And because that factor appears twice, they would call this a repeated solution. But it is still the only solution, just the number 1/3. Right? And of course, I'll leave it to you this time to check it. Actually, I can check it out loud pretty quickly. If d is 1/3, right, 1/3 squared is 1/9, and then 144 times 1/9 would be 16. 96 times 1/3 would be 32, and 16 minus 32 is indeed negative 16. This totally works. Right? And that, again, is the only solution. Right? It's just, sometimes people would say it's a solution twice, because there are 2 factors of it, but it's still just one number. Right? It's still just the only solution here is 1/3. Okay, great. Yeah, I see they got the repeated solution. They did it twice. There's no need to write it twice if if you have the same factor again. Alright, so here's one where it's already written in the way we want it, a product equal to 0, so I can use the zero product property. So we're asked to solve this equation. One factor is 7 times m times, and then the other factor is 4m minus 2 equals 0. Right? So I already have a product equal to 0. So we can apply the zero product property right now. There's no need to multiply things out. So by the zero product property, either 7m equals 0 or 4m minus 2 equals 0, or both. Now the first equation is no problem. Just divide both sides by 7. You get m equals 0. There's one solution of the equation. And again, you can check it. It should work. The other one you would add 2 and then divide by 4. M equals 2/4, but that reduces to 1/2. And again, check these. I'll leave them to you to check. But when you plug either one in, you're going to get one of these factors to be 0, and anything times 0 is 0. They should both work. So the solutions of this equation are 0 and 1/2. And again, you're asked to separate multiple answers by commas. 0, 1/2. Great. Alright, so back to here's a quadratic equation. I got plenty of space here. Now this is already set up to where I can just start factoring. We have x squared minus 3x equals 0. Right, it's already set up the way I want to start factoring. Everything on one side, 0 on the other. And then when you factor, I mean, the greatest common factor of these two terms is x. So I pull the x out, and then we have x times x minus 3 equals 0. And now I have what I want to be able to use the zero product property. A product equal to 0. All right, so by the zero product property, either the first factor x equals 0 or the second factor x minus 3 equals 0, and then solving these we get x equals 0 or x equals 3, and again you can check them, but they should work. Right, and they definitely do. Right, I can see it right now. So again, x equals 0, 3. Right, the two solutions. Wonderful. Alright, so this one is already factored. I've already done 2 of these. You got a product equal to 0 already. So either the first factor, 12a equals 0, meaning a equals 0. Right, just divide both sides by 12. So 0 is a solution. Or the other factor, 11a minus 1, would be equal to 0. And in that case, you would add 1, divide by 11. A would be positive 1/11 is the other solution. So 0, 1/11. Right? This should be the easier of the three, the easiest of the three objectives in my opinion. They've already got written out as a product equal to 0, so you can apply the zero product property right away. And I got just one more like this. Now look, 6z plus 6 squared. Remember what that means. That means it's 6z plus 6 times 6z plus 6 again. So you just have the same factor twice. And the only number that you can square to get 0 anyway is 0. So again, no need to write out both factors. Just say 6z plus 6 must be 0 then. And if 6z plus 6 is 0, z must be -1, right? Subtract 6, divide by 6. And that's the only solution here, right? And it would be a repeated solution. All right. There's another equation. All right, this one's very simple. It's already set up where everything's on one side, zero's on the other. So I can very quickly write this one out. In fact, I got room up here. This will be a short one. We have q squared plus q equals 0. everything on one side, 0 on the other. Now I just factor this polynomial on the left here. Well, that would just be pulling out q. You have q times q plus 1 equals 0. Apply the 0 product property. So because I have a product equal to 0 now, so either q equals 0 or q plus 1 equals 0. And then, q equals 0, that's solved. And q plus 1 equals 0, q would be negative 1, and there's your solutions. All right, check them, of course, check them back in the original equation. They should work. Right. So 0, comma, negative 1, right, the two solutions to that equation. All right, great. All right, so here's one where I need to do a little more manipulating. I'm moving some stuff around first. All right, so we have 12a squared plus 28a equals negative 8. First I would add the 8 to get everything on one side in that standard form. So now I have 12a squared plus 28a plus 8 equals 0, right? A quadratic polynomial equal to 0. There is a greatest common factor over here of 4. I can factor a 4 out, and that would leave me with 3a squared plus 7a plus 2 equals 0. And then we can factor this with the AC method. I'll do this off to the side, maybe refresh your memory. 3a squared plus 7a plus 2. Remember, you take the a times the c, the lead coefficient, times the last coefficient. 3 times 2 is 6, and then you look for factors of 6 that add up to 7, which would be 6 and 1. And then you rewrite the middle term as 6a plus 1a and then grouping. Right? The first group I'd have 3a squared plus 6a plus, and then the second group I'd have 1a plus 2. Factor the first group. Those have a common factor of 3a, and then what would be left over would be a plus 2. The second group, the greatest common factor is 1. You can write the number 1 there if you want, times a plus 2, and then these both have a plus 2 in common, right? So 4 times a plus 2 would come out, and if a plus 2 comes out, the other factor is 3a plus 1. Alright, so I factored it completely, and now I have a product equal to 0, and I'm going to apply that 0 product property. So either 4 equals 0, but nothing's coming from that. Alright, there's no solution to that one. Or a plus 2 equals 0, or 3a plus 1 equals 0. Right? If a product equals 0, at least one of the factors is 0. So from a plus 2 equals 0, we get a equals negative 2. From 3a plus 1 equals 0, we get a equals negative 1/3. And again, if you're doing everything correctly for these polynomial equations, these quadratic equations, these should be good. But I'll put the little check marks next to them just to remind you, check, go back to the original equation. Plug in negative 2 for a, plug in negative 1/3 for a, and you should get negative 8 equals negative 8. It should be true. So again, separated by commas here, negative 2, comma, negative 1/3. Great. All right, and then the last problems should be those application problems, those word problems. All right, so this is oh wow. They give us the equation. If the side of a square patio is increased by 4 feet, the area of the patio would be 196 square feet. So you see, they take the side S of the original square, and they're adding 40 side. So now the area, instead of being S squared, is S plus 4 squared, and the area of this new one is 196. So they give us this equation, and they're asking us to solve for S, right? So I'll write out this equation and solve for S. So this one we don't even have to really set anything up. So we have the quantity S plus 4 squared equals 196. Alright. Now, if you remember that 196 is 14 squared. And you'd be like, oh, s plus 4 could be either 14 or negative 14, then s got to be 10 or negative 18. You know, we'll see that s is 10 in the end here. But if you don't recognize that, let's actually multiply this out. So this left side would be s squared plus 8s plus 16. Right? That's s plus 4 times s plus 4. Right? Equals 196. And then I take away 196. You know, I'm doing what I've been doing for all the equations in this video. Now 16 minus 196 would be negative 180. And then we have a quadratic here equal to 0, like I want. And it's a quadratic where the lead coefficient is 1. So once again, all I need to do is find factors of negative 180 that add up to 8. And that would be, just 18 and negative 10. All right, so s plus 18 times s minus 10 equals 0. And then I can apply that zero product property. Say, you know, because I have a product equal to 0 now, so either the first factor, s plus 18 equals 0, or the other factor, s minus 10 equals 0. And solving each of these, we get s equals negative 18, or s equals 10. Now these are both solutions of the equation. They both work. But remember what s represents. S represents the side of a square, the side length of a square. So not that one, not the negative one. Right, it's 10 feet. The side of the original square was 10 feet then, 10 feet by 10 feet. So s equals 10 is what I'm filling in the box here. Now again, negative 18 would work in the equation, but it doesn't work with the whole concept of the side length of a square, right? Sides can't have negative lengths. Great. Okay, there should be just one more of these. Alright, so we have a reflecting pool. It is shaped like a right triangle with one leg along the wall of a building. The hypotenuse is 9 feet longer than the side along the building. The third side is 7 feet longer than the side along the building. Find the lengths of all three sides of the reflecting pool. Alright, so we got this. It says, you know, so say here's the building, let's say. The side of the building. And they create a pool that's in the shape of a right triangle off the side of this building. Like that. Right, all 90-degree angle there. Remember what a right triangle is. Right. See, one of the legs is on the side of the building. I'll call that x feet. They said the other leg, the third side, is 7 feet longer than the side along the building. So this is x plus 7 feet. And then they said the hypotenuse, remember the hypotenuse is the side opposite the 90-degree angle. The hypotenuse is 9 feet longer than the side along the building, so x plus 9 feet. And now they want us to find the length of all three of these sides. So basically, if I find x, I'll know the side on the building, and then add 7 for this side, and then add 9 for the hypotenuse. Now, this is a right triangle. Right, this is a right triangle. That means the Pythagorean theorem applies. Right, this is kind of just assumed knowledge here. That, you know, if I have a right triangle, I should assume that, hey, I can apply the Pythagorean theorem if necessary. And that looks like it's necessary here. So remember, the Pythagorean theorem states that the sum of the squares of the legs, so x squared plus, and then the other leg is this x plus 7 feet squared, will be equal to the length of the hypotenuse squared, right? The quantity x plus 9 squared. And this is a quadratic equation. We'll see. All right, we'll see that this is actually a quadratic equation, And I'm going to do the same thing I've been doing where I get everything to one side, 0 on the other, and then factor and then solve using the zero product property. So this is x squared plus, now x plus 7 squared is x squared plus 14x plus 49 equals, and then on the other side, x plus 9 when you square it would be x squared plus 18x plus 81. And then I just take everything to the left. So I'm going to take away x squared, I'm going to take away 18x, I'm going to take away 81. Alright, so that'll get rid of this x squared here. So I'm left with on the left side x squared minus 4x, right? 14x minus 18x. And then minus 32 equals 0. Alright, 49 minus 81 would be minus 32. Now I have a quadratic, and once again it's a quadratic where the lead coefficient is 1, so I can easily factor this. I just need to find factors of negative 32 whose sum is negative 4, and that would be negative 8 and positive 4. Right? So this factors to x minus 8 times x plus 4, and I'm hoping to see that, by the zero product property here, either x minus 8 equals 0 or x plus 4 equals 0 right now that I got a product equal to 0. And then we solve these. So either x equals 8 or x equals negative 4. But remember, this x represented side lengths of a triangle. One of the side lengths of a triangle. So it can't be negative 4. It's got to be 8. So this has got to be 8 feet. This side is 8 plus 7, replacing x with 8. 8 plus 7, that side's got to be 15 feet. And then x plus 9, 8 plus 9 is 17 feet. Right? And these three numbers, 8, 15, and 17, do satisfy the Pythagorean theorem. 8 squared is 64. 15 squared is 225. Right? Add those up and you get 17 squared, which is 324. Right? So, I'm sorry, not 320. Not 324. 289. Right? 225 plus 64 is 289, which is 17 squared. So those numbers do satisfy the Pythagorean theorem. So x equals 8 works, and those side lengths are the ones we're going to enter: 8, 15, and 17. So the side against the wall, 8 feet. That other leg, 15 feet. The hypotenuse, 17 feet. And that should be good. Great. And they might draw a little picture down here. I don't know. No, they didn't draw a picture at all. Drawing pictures never hurts, right? But yeah, the key was the fact that you're working with a right triangle, right? So the Pythagorean theorem should apply if you need to, right? Which it was needed here. And that should be it for this preview version of this assignment. And like I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself, but the objectives are all the same. The structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment yourself. And thank you very much for watching.